The topic we thought might be interesting to look at today is how to stabilize execution plans as you go through the process of upgrading your Oracle database. Now, in the Oracle environment, any sort of upgrade, perhaps even just a release update, can be frightening because of unexpected impacts on SQL performance. So what our agenda is to outline why this performance instability can occur. Why do we have this upgrade paranoia? Why can things go so wrong with an upgrade? Then we'll go through two techniques for stabilizing your SQLs through the upgrade procedure. First, a precisely targeted approach, where you, the DBA, will identify a problem, you'll determine the cause, and you'll arrive at a solution. And that's a nice way to do it, but it's going to be extraordinarily time-consuming, very resource-intensive, which is why I would often recommend a different approach, which is where you stabilize the entire environment. A much more general approach. There's no need to think. You just rely on Uncle Oracle. Uncle Oracle will look after you through a declarative technique. Both techniques reach the same end point. There's a process Oracle calls evolution. And through the process of evolution, performance of your SQLs should improve over time and never degrade. It's a self-learning mechanism. Evolution. Improvement over time without any performance regression. Well, I say performance will never degrade. It won't degrade because of execution plan changes. And remember, execution plan changes can occur at any time for many reasons. You've got your adaptive features, dynamic sampling, objects and system stats. And in this particular case, it can happen because of an upgrade. So what's the problem? Well, I'm sure everyone here, I'm sure we've all done numerous upgrades. And when it comes to performance, typically you'll find that 90% of your SQLs run the same before and after, perhaps 9% run better, and for 1% of your SQLs, performance drops through the floor following the upgrade. And if you are unfortunate, it's those few SQLs that regress. They're the ones that matter. Now, why would SQL's performance degrade and upgrade? Well, typically, there's two reasons. As you go through the releases of Oracle, you get dramatically different, you get enhancements and changes made to the cost-based optimizer. The cost-based optimizer is continually improving, being improved, new algorithms, new techniques. Now, Oracle has a group of people with brains the size of planets working on optimization algorithms. So as you upgrade, you will get different versions of the optimizer, different capabilities. You will get it generating different execution plans for the same SQL. Another reason for plans changing, unexpected results, is to do with statistics. The techniques for gathering statistics change quite dramatically as you go through the releases. The first example I'm going to give you shortly demonstrates a problem, a potential problem caused by the way statistics gathering changed between release 11 and release 12, for instance. So changes to the optimizer can result in execution plan changes. Statistics as well can cause the optimizer to react in a very different way.
John, I have a question. Is it typically safe to apply an RU, or is that introducing potentially the same problems as an upgrade?
Theoretically, an RU is going to be safe. Theoretically. Remember, an RU should just be a whole bunch of patches bundled up together and fully integration tested. Unfortunately, I'm sure some of the people here will be aware of the fact RUs can sometimes cause problems. And that's why within Scale Builders, within our technical team, we decided quite recently that we're not going to apply RUs there's too much possibility for problem, we're going to apply RURs. So instead of release updates, we apply the release update revisions. Now, RUs can sometimes cause problems on these lines. The release update revision, published worst case 3 months later, should get rid of any of them. So the answer is, theoretically, RUs are okay. I've decided to go for the RURs instead.
Great, thank you, John. Folks, any questions on RU versus RURs? Just go ahead and chat them in. Back to you, John.
Now, the way to stabilize your system through the upgrade process is through baselining. It isn't incidentally just stabilizing through upgrade process. It can stabilize your system through gathering statistics, through parameter changes, through platform changes. Convert your system from single instance on Windows to a 4-node rack on AIX. Baselining can stabilize your system through all those changes. It's also known as SQL Plan Management, SPM, and the API is called, indeed, DBMS SPM. So what's the issue and why do we need SQL Plan Management? It's because Oracle does dynamic SQL parsing. Just to make sure we're all on the same page of the manual, as it were, what is dynamic parsing? A statement hits the optimizer. If the statement is not found in the library cache of the shared pool, the optimizer develops an execution plan. This is the hard parse. That plan will be based on information available to the cost-based optimizer at the time the parse is done. That information will be information such as object statistics, information about the objects being addressed by the statement, system statistics, some other factors as well, current state of the environment. It is also dependent during the parse on whatever optimization algorithms are available for your exact release of the database. Now, this dynamic parsing should be a good thing. It means you get the best plan that the current version of the product can produce for the current state of your data. However, it does mean that plans can change unexpectedly following upgrade. That is by design. It's meant to be a good thing, but it can go wrong. SQL Plan Management, baselining, uses baselines to ensure that any changes will be checked to ensure that they are for the best. So, what does it do? Well, a baseline is a stored execution plan. You parse the statement, generate an execution plan, run the statement. If at any time in the future, for example, after an upgrade, the cost-based optimizer comes up with a new plan, that plan is blocked. So you capture the execution plan and use it. Generate a new plan, you block it. Your SQLs continue to run with the previously generated plan. That stabilizes the system. And that will prevent problems following upgrade. But it will also prevent improvements following upgrade. You've not merely stabilized the system, you've frozen it. And that's where the concept of evolution comes in. The evolve process tests those new plans. It tests them to see, are they better or are they worse? And if the new plan is a regressing plan and cause the SQL performance to degrade, it is permanently blocked. If, however, the evolution process realizes the new plan is an improvement, then it can be brought into use. So that's what baselining is. You stabilize your system by capturing and storing execution plans. Any new plans come up are blocked until they are tested through the evolution process. So yes, you delay improvement until plans have been evolved, but you permanently delay regression.
A few questions in the queue, John. PSU versus RU, are they the same thing?
I think they are. It's that continuous messing about with naming of these things. We've had PSUs, CPUs, SPUs, bundle patches. Now they call them RUs. The only real significant difference I'm aware of is that the RU isn't just a bunch of patches that are integration tested. It will also change your release number. An RU will take you from 19.6 to 19.7, for instance, which the PSUs didn't. But for practical purposes, they are indeed the same thing.
You know, Oracle advertises, seems to, that the database, new versions of the database will come in with improved performance, pretty much a standard sales tactic. So, you know, why is it that upgrades cause mostly performance issues?
They don't cause most. They don't necessarily do it. You might do many upgrades and have no issues at all. And remember the way I crudely described it 5 minutes ago. You upgrade, 90% of your SQLs run the same, 9% run better, 1% degrade. You might never even notice that any SQLs have gone bad. As a general rule, upgrade is a good thing. But we're all IT professionals. General rules aren't good enough. There's always the possibility of things going wrong. And just because 99% of your code is perfect or improved doesn't mean that your end users won't suffer for the 1% that's gone bad.
As you said, John, Oracle has used many, many different names for RUs, like, for example, CPU and PSU. Are the RUs announced and delivered quarterly?
Yeah, they come out quarterly. And so the release updates are quarterly, and the last one was April. The RURs, the release update revisions, are also released quarterly. So typically, the January RU was indeed released in January. Then the April RU was released in April, and the January RUR was also released in April. And that's the one we applied to most of our production systems. So we applied the January RUR in April rather than the actual April RU.
Thank you, John. Back to you.
Okay, so baselining in general. Moving on from there, just a brief mention here. I hate talking about money because I'm not very good with it. And well, if I understood licensing, I'd be a salesman and rich instead of a poor technician. However, I want to mention a bit about the licensing issues for baselining because it's been changing through the releases. When first introduced in release 11, baselining was Enterprise Edition only. Enterprise Edition only. And that meant that for Standard Edition, you had to use stored outlines. Stored outlines came in with release 8 point something. I've been using them for decades. But stored outlines were officially deprecated when baselines came in. But to use baselines, you had to have Enterprise Edition licenses. Now, in release 12, there was more functionality added to the baselining mechanism, but that functionality required Enterprise Edition plus the tuning pack. And to this day, for the full functionality of SQL Plan Baselining, you do need Enterprise Edition plus the tuning pack. It allows complete automation of the whole process. And using a purely declarative technique, which I will demonstrate, we can ensure that performance will never degrade. And you don't have to use your brain. You just let Oracle get on with it. Using engineered systems, particularly Exadata, there's even more functionality. However, in the current release, we'll release 12 and later, baselining is available in Standard Edition as well, but with certain limitations. So I'm not familiar with exactly what all the limitations are, so I'm not any sort of licensing expert. But the general approach to take is full functionality, Enterprise Edition plus the pack. Without the pack, the DBA has to do a bit more work. With SE2, he has to do a bit more work still. I would like to emphasize this point, by the way. Without the facilities, the tuning pack and the rest of it, you can still get all the functionality. It's just that your DBA has to use his brain to make it work. And within Skill Builders, we are very good at getting Enterprise Edition type functionality out of SE2 environments. Nearly everything you can get with the tuning pack, you can do the hard way, going through APIs, using your brain. But just bear in mind, there are some licensing issues here. What I'm going to demonstrate, by the way, will be the full functionality of Enterprise Edition plus Tuning Pack.
Quick question, John. If Enterprise Edition does the plan evolution automatically, then is there no need for baselining or SPM for it?
You have to enable the mechanism. You have to enable it, and then you can let Oracle get on with it. But the enabling process still has to be done by the DBA. He just doesn't have to worry about it subsequently. So let's have an example. Whether you can actually take this approach depends on how much resources you have available, how much time you have, how important the environment is. But in an ideal world, this is the approach you will take. You will evaluate all your SQLs. You will identify the SQLs that are or might be in trouble following an upgrade. One would hope that you would look at all your SQLs. It'll only be a tiny proportion of them that might have a problem. That's what one would hope. One would hope that most of them will be the same or better. But if you have the time, the motivation, the opportunity, you would identify the SQLs that you think could have problems or are definitely going to have problems. As an example, I'll simulate a case of an upgrade from release 11 to release 19. Remember, release 19 is just the terminal release of 12c. So we'll go through a case of an execution plan changing through that upgrade. Now, let's see my example. So in this window here, I've got a release 11 database, 11.204. And in this window here, I logged on to a 19c, 19.3 unpatched 19.3 database. Now, as an example, I'll just connect to a user called JW in release 11. And I'm going to create a table. Create table dept to select star from scott.dept to create a dept table, and then create a table based on the structure of emp. Insert some rows into it. So first off, I'm going to insert into dept, select star from scott.dept. There go the 4 rows. And then I'll insert into emp. Right. Commit. Run a simple query. So I'll set auto trace trace only explain. And a very simple query, I shall select star from dept join emp using dept no. Well, how is release 11 going to do that? Right. Release 11 wants to do that with a hash join. Hash join using dept as the build table and emp as the probing table. Right. I'll actually run the statement rather than just auto trace it. So I'll just back come the 14 rows, hash join, dept to emp. Repeat the process in release 12. So what would happen in release 12 after the upgrade? Connect JW/JW. So, same process. Create my tables, insert the rows, and try running the statement. Well, set auto trace on, trace only explain. How does Oracle want to run the statement? Look at that. Exactly the same code, exactly the same code, no changes of any sort, but we've got a different execution plan. The join order has flipped. We are now using emp as the build table for hash join and dept as the probe table. Now, I'm sure you all know about tuning SQL, but in case any of you are not so familiar with tuning SQL at this level, the most critical decision the optimizer has to make is join order. If you get the join order wrong, your SQL has no chance of running well. Absolutely no chance. And the join order is flipped. This is the sort of the change that can cause disastrous results in performance. The reason it's happened, by the way, is due to a change in the way Oracle gathers statistics when you insert rows into tables with direct load between release 11 and release 12. That's just a by the by. It's something that should be an improvement. In this case, has caused a problem. In release 11, if you look at these estimates, Oracle has really no idea what's going on. And it's just made a complete guess about the join order, and it's got it right. It's applied heuristics, it's made the right decision. Release 12 and later is more intelligent. It's actually got an estimate there, which happens to be correct. But with partially correct information, it's made an appalling decision. So that's what's going on. So we've identified a problem SQL. What do we do to fix it? Right, we create a baseline in the old system, the 11G system, and we transfer it to the upgraded system. So to create the baseline, it's all done, by the way, with a package, DBMS SPM. It's a bit of a pig to use as DBMS SPM, but that is the API that I'm sure some of you will become very familiar with if you aren't familiar with it already. So first off, I need to capture this execution plan in release 11. That we do with DBMS SPM, and the packages and the procedure I'm going to use is load plans from, or function I should say, is load plans from cursor cache. There are all sorts of options here. You can see it's even overloaded there. There are any number of possibilities for this, for how you capture the plans. But one way or another, in your old system, before the upgrade, you capture the execution plan. Now it's a function that returns a binary integer. So I'll have to create a variable. And then I shall, before I do that, there's my plan hash value. The functions take a SQL ID and plan hash value. So I have to get the SQL ID for that statement. This is the sort of process you would go through. And so get the SQL ID for that execution plan, which does the hash join the way we want it. Set auto trace off. Right, there's the statement. There's the SQL ID. So I've got the plan hash value already, which was that there. To stick that into the function with this call here. Oops. Execute, my return value will go into DBMS SPM, load plans from cursor cache, that SQL ID, that plan. And that will create a baseline for the statement. And we can see it if we query the view, select plan name, SQL text, and DBA SQL Plan Baselines. There it is. And that's my baseline, SQL plan, so and so and such and such. And you can see just with one more query that that plan was a manual load because I did it by running that call there, and it's accepted for use. It's accepted for use. I now need to transfer that to release 19 because release 19, remember, is still using the wrong plan. Right. You have to go around the houses a bit to do that. But to begin with, there's this function call or procedure call here. DBMS SPM create STG tab baseline. This creates a table, and I'm calling it from 11. And that table is specifically designed for storing baselines. Then we have another call. Execute DBMS SPM pack STG tab baseline. And if you look at all the arguments, you'll see the pack So now using pack STG baseline, any number of other arguments. But in principle, the table into which I'm going to load the baseline, and then the name of the baseline I want in there. So that's this call here. I'm going to take that baseline I just captured, save it in that table. Now I've got to transfer it to release 19. So here's my upgraded database. Perhaps it's a test system at this stage, who knows. But in my release 19 database, the way I'm going to capture it, and there's nothing clever about this, so I'm just going to use data pump. So I'll create a database link called 211, and that logs on to my release 11 database, and then use data pump import to transfer the table across. So nothing special about this at all. IMPDP, just a network import. So I'm reading the table from 11 through the network link into my release 19 database. So perfectly standard use. It's just a table like any other. It just happens to be a table that contains baselines. And there we see the tables come in with its one row. Next step, I need to extract the baseline from the table. And that is done with the unpack function. Function unpack, which table do you want to get it from? Right, and again, it returns a number. So I shall unpack everything in that table with DBS SPM unpack STG tab baseline. That will have got the baseline into my release 19 database. And we should be able to see it at this point. For example, if I go to run a query here, select SQL text, plan name, origin accepted, and DBA SQL Plan Baselines. Oops, set auto trace off. Sorry about that. And there we see it's come across. There's the statement, there's the plan for it, manual load, accepted for use. What now happens when I run the code? Set auto trace on, explain, and just run it. Yippee! We've got the join order we want. Why? Because we use the baseline. So that's the hard way of doing it. We've identified a statement that went bad following upgrade. We created a baseline with the plan we wanted, transferred it to the upgraded database, and there you see the SQL is stabilized. It works, but it's a lot of work. It's a lot of work. There's also, of course, the possibility that the new plan that got developed might actually be better than the old one. Let's see if there is a new plan in there. And if we look at it, look at that now. Going to DBA SQL Plan Baselines, there are now two baselines. That's the one that was manually loaded, but there's another one there, auto-captured. Interesting, isn't it? That will be the plan that was developed by the hard part in release 19. Automatically captured, but blocked from use. It's not accepted. We don't ever want it to be accepted because we know it's bad. But that would lead us on to the evolution process.
Hey, John, before I forget, just save us 10 minutes or so at the end. I've got a couple of questions I'd like to pose at the end in the queue already. Yeah, quick break, folks. Let John get a glass of water, take a quick sip of water. So This is Dave again. I just like to tell you about us, what we do at Skill Builders, and maybe you'll keep us in mind when you have a requirement. Of course, we offer Oracle database administration services, and that's either led or done by Oracle Certified Master John Watson, who's teaching us today. You know, we can provide slightly different variations of services, you know, for you. If you want to learn as a DBA, if you'd like to learn what you ask John to help you with, well, then we call that a mentoring engagement, and that's exactly what happens. John will work with you to come up with an action plan and work with you to apply that action plan, so you can see step by step how the project or task goes. This could be an assist with an upgrade of a database or anything, implementation of RAC, data guard, failover, all of that option stuff that Oracle has. Of course, if you simply want us to do it, to take it off your plate, we're happy to do that. Act as an extension of your team and coordinate the actions that John takes with your other teams, tasks, your other operations that are going on. So, and keep you fully in the loop and communicating with you as to where we are in the project. So those are services that we'd like to provide for you guys. If you have a requirement, perhaps you just want to get something done faster and learn how to do it, great. We can really help there, or we can take it completely from you and let you know what's happening, and of course, magically it will happen and it'll all be good. So with that, keep us in mind. skillbuilders.com is our website, and I'll pass it back to John now. Thanks for the time.
So what I demonstrated a couple of minutes ago is the ideal solution, where you, the DBA, identify problems and deal with them on a one-by-one basis. But it's a huge amount of work. And that's where there's an alternative approach, which is purely declarative. You stabilize the entire workload. You probably have thousands of SQLs, tens of thousands. Many sites have no real testing capability. They certainly don't have time to look at all those SQLs one by one. So what do? You've got to stabilize everything, and you will be seriously reliant on automatic routines. Now, that's what we can do. The idea is you capture plans for all the SQLs. So at some point before you upgrade, you start this capture. Easy, it's just setting a parameter. And you're going to end up capturing perhaps hundreds of thousands of execution plans. Perhaps hundreds of thousands. Maybe millions. Is that a problem? Not really. It requires a bit of thought in terms of space and your sysorgs table space and so on. But the idea is you capture plans for all your SQLs. Then you do your upgrade. Well, because every SQL you run, assuming you did get the entire workload, you might be capturing for a couple of weeks. But if you did get the entire workload, you've got a plan, a stored out, a baseline for every SQL. So after the upgrade, nothing's going to change. Nothing's going to change. All your SQLs will run with exactly the plans they had before. Right. Well, that's good, because it means that there'll be no performance degradation. It also means, of course, that there'll be no performance improvement. Begs the question, why did you bother to upgrade? And that's where plan evolution now becomes essential. Because if you don't do the evolution, you will never get any improvements. Now, in an ideal world, you will have paid Uncle Oracle enough money to have got the licenses for complete automation. Right. That means you can rely on the auto-evolve task. That was introduced in release 12. Relying on the complete automation means all changes following upgrade are blocked. So things run exactly as they did before. But then, over time, new plans that are better will be let through, while plans that would cause degradation are permanently blocked. And it can be completely automated. So basically, improvements are just delayed. You'll do the upgrade, nothing changes initially, but as the few days go by, things will get better without the DBA or the developers having to have any involvement at all. How long the improvements are held back for, well, there's any number of factors behind that. But one thing you do get with the latest enhancements with the Exadata environment is what they call the high-frequency evolution task, and that can run every hour. So the delays may not be long, but it depends to a certain extent on your environment. If you do not have all the licenses, you don't have the tuning pack, you're not an Exadata, maybe you're an SE2, we can still automate this process. We do have programmatic techniques for doing it, but it's no longer purely declarative. But we can still implement this. We can implement equivalent functionality without relying on the licensed capabilities. So how does it work? Right. All we do is set two parameters. So show parameter baseline. These are the two parameters introduced in release 11. These are the default values. Optimizer capture SQL Plan Baselines false, optimizer use SQL Plan Baselines true. That's the default value. Now, I'm going to set that to true with alter system set. I'm going to work exclusively in release 19 for the moment, but I'll show you how we'll simulate an upgrade. I'll set that to true. Oops. And what that means is that from now on, with just that one parameter, Oracle will capture execution plans for every SQL statement. By default, everything. You will end up with hundreds of thousands of plans saved as baselines. You don't have to do it that way, by the way. You can apply all sorts of filters, only capture plans for a particular schema or whatever. There are many filters you can apply, but this is declarative technique without even thinking. It's brainless DBA, this, and there's nothing wrong with that. It works. So that's going to capture all my execution plans. The second parameter is already on true because that's the default value. That allows Oracle's optimizer to use SQL Plan Baselines if they exist. And as you saw in my previous demonstration, the baseline was used because that parameter is defaulting to true. So we capture plans. You would then upgrade the database. All those plans will then be used. You've stabilized the system. So your execution plans won't change, not through upgrade, not through new statistics, not through parameter changes, or even within limits through schema changes. A schema change such as dropping an index might make a baseline invalid, but within limits, you stabilize the system against any sort of change. But then we get the clever bit. If any change forces a new hard parse, which produces a new plan, such as the new plan we saw in my previous demonstration, the new plan gets blocked and the baseline plan is used. But the new plan is also saved for evolution. Now, the evolution process can be manual or it can be fully automatic. And of course, I'm going to demonstrate the fully automatic mechanism. So, here's my query. Yeah.
Pardon, quick question. Can the evolution task be used in the case of a platform change as well, like moving from Spark to x86?
Absolutely. It's not just platform change. It would also be going through, say, operating system change. Yeah. It's all happening above that level.
Thanks, John.
Yeah. So what I'm going to do is I'm going to put my 19 system in effect back to 11.204. So I'm telling my 19C database to pretend it's 11G. Now the statement I'm going to run is this. Oops. Select dname, select average cell from emp, where emp.depthno equals dep.depthno from dept. So this is, I'm projecting a scalar subquery. This is a pretty horrible thing in the Oracle environment, projecting scalar subqueries. So we run the statement, and back come my department to the average salaries, and that will have been done in 11G, effectively. So how did Oracle actually run this? What did Oracle actually do? Right, I'm going to DBMS Plan Display Cursor, and here we see what Oracle did. So that statement, remember, was select dname, and then I'm projecting that scalar subquery. Well, look at the plan. Operations 1 and 2 are full scan of emp and aggregation. That's generating that column value. And look at it. Oracle did it 4 times. Why? Because we're doing a full scan of dept to get back the 4 rows. And for each of those 4 rows, we have to run that subquery. It's a horrible correlation. Imagine if there were 1 million rows. You'd be running that subquery 1 million times. And there are some optimizations to do with caching and so on. But in principle, it's a horrible correlated subquery. Right. Now, let's simulate an upgrade. I'll put the optimizer up to the current release. Oh, note that execution plan will have been captured, and we should be able to see it. There it is. There's the query, and we've captured it, but this time with auto capture note, and that's the accepted plan. Right, upgrade the database to 19 with this. Set my optimizer features to 19.101, and our users run the application. What happens? Okay, so we've done the upgrade. Oops. Sessions. Oh, don't be stupid, John. Sorry, set auto trace on explain. That's better. Our end users run the application, that same statement that projects the subquery, and we've got the same plan because there's the baseline. So we captured all our baselines, upgrade the database, nothing's changed. That would have stabilized the system through the upgrade, so performance can't degrade, but it can't improve either. And this particular query, release 12 and later, should be able to do a much better job. Take a quick look at the baselines, and we'll just see. You can see I'm capturing all my plans being captured. Oh, look at that. That's the original execution plan, which is accepted for use. But then the same statement now has another plan. My release 19 database came up with another plan, but the baselining mechanism has blocked it. It's not accepted. Is that plan better or worse? I don't know. I could test it, but I'm not going to, because we've got the auto task. So if we wait till tomorrow, the auto task runs overnight, and tomorrow we'll test that new plan. But I'm not going to suggest you wait till tomorrow. So what I'll do is I will tell Oracle that it's Wednesday night. So I'll tell schedule, the DBMS scheduler to open the Wednesday night maintenance window. So as far as Oracle is concerned, it's now Wednesday night. The auto task should be running. Tuning advisor tasks, among other things, will run the auto evolve task. So at this precise moment, all new plans should be being detected and tested. So let's move on to Thursday morning. I'll just close the Wednesday night window, close the window. It's now Thursday morning. Right, what happens when our end users run the application? So we'll run the code. Still using the base plan, using the baseline. Maybe I didn't let the window run for long enough. Open it again. There's also the possibility the improvement isn't good enough. Close. No, I'm not getting what I wanted. The evolution is not giving me the improved plan. And if we look at the baseline, or maybe it will if I just give it.
Live demonstrations involving tweaking around with the cost-based optimizer are fraught with type of issues.
They are indeed. It doesn't want to evolve it. Okay, the thing I'm going to do is look at the auto evolve task and see what it came up with. So at least we'll see what it did and why it didn't do what I wanted. So the task runs every night and should detect all new plans. Right, so the task ran, interrupted. I didn't give it long enough by the look of it. Okay, so let's give it a bit longer.
Maybe a bit of time for questions?
Definitely.
Cool. Yeah, so you were teaching us about the licensing issues, John, related to this. Question in is downgrading of the database. Will that revise the license usage back again to what it was?
Oh, I did say I'm not any sort of expert on licensing. Mm-hmm. I wouldn't like to say. I really wouldn't.
Fair enough. There's another format. There's several formats of auto trace. Why did you not choose to set auto trace only explain? Did you use a variation of that?
There are all sorts of variations, and trace only explain is very useful. It's like a shortcut for explain plan and then querying, then running dbnsx plan.display. It's a very useful one indeed. But you've got to bear in mind that that's only explain plan. It might not be the plan that actually was used. In this case, it probably would be, because there are no bind variables or anything like that. But it's something I use all the time. It's very useful, but you just have to bear in mind that it might not be what actually happened.
Yeah, it can mislead you. Be careful with that. Last one, John, speaking about your demonstration, can you show or extract the explain plan of the new baseline?
Yes, I can. I'll just have to work out. Let's just see if I can get this working first, though. So we've given it more time. I'll close the window.
No worries.
Ah, it's done something this time. Let's run my code. So I'm actually going to run it note, and then I'm using explain plan. So it was just a matter of waiting. So when I really did give the auto task long enough, I've now run the same code. Hey, presto, we've got a better plan. Basically, the current release of the optimizer can unnest the correlated subquery and rewrite it to a join, which release 11 couldn't do. So my apologies for not giving the task enough time, but I hope that's giving you an idea of how the DBA can just use a declarative technique and let Oracle get on with it. All you do is set 2 parameters to true before you upgrade or before your platform change, whatever else it is, run your entire workload. leave it this way for a month, gather baselines for everything. Then you do your upgrade, whatever else the change it might be. Nothing changes. But then every night, this task runs, provided you give it long enough. This task runs. And what it did, it gives you quite useful information. Here we see the task ran successfully, and it ran to completion once they gave you enough time. It found that this statement had a new plan. It compared the new plan with the old plan, base plan, test plan, works out that the new one is 3 times better than the old one, okay, and accepts it. And that's why, without the DBA or the programmers having to do anything at all of a sudden, we no longer get that. We get that. Whereas, had the new plan proved to be worse than the old one, it would have been permanently blocked. So in summary, any sort of changes can have pretty unexpected results. And baselining may well be the answer. Of course, the way I've demonstrated it is trivially simple. It's actually quite a lot more complicated than that. But in general, baselining gives you a guarantee that performance will never degrade. But over time, as the jobs run, performance will slowly improve. Well, performance will improve. So improvements are held back for a short period of time until they're tested and proven to be beneficial. If you have the licenses, the process can be totally automatic. If you don't have the licenses, SE2 or whatever, there are still programmatic techniques that we can use to get a very similar effect.
Great, John. Thanks for the time for the questions. Do you need to worry about purging older baselines, perhaps space issues and sysocs?
Yes, you do. There are all sorts of defaults. You can specify a space budget in the sysorcs table space, and it will overwrite baselines once it reaches that space budget. There's also a default for unused baselines being dropped. So yes, there's automation, but the automation might not be suitable for any particular establishment. It might well mean that you had umpteen gigabytes of sysorcs and you don't want all that. So yes, you've got to put some thought into that.
Great. Related question, can you identify obsolete baselines and delete them?
You can indeed. If you look at the view, DBA SQL Plan Baselines, you've got a lot of information for each one. When it was created, we already show how it was created. Is it enabled? Is it accepted? Can it be reproduced? Maybe there's some change that means it's no longer useful. So you can get information about them, and then using the API, you can manually manipulate the environment with, you can manually accept a baseline, or the alter function lets you get rid of them, delete them, remove them, adjust them, fix them. You can change all of the attributes programmatically through this API.
All right, great. Next question, I think, is sort of a wide open to SQL tuning, which, John, I can point the students today at the how to read the execution plan, but you'll direct me for the best path here, John. What parameters influence optimizer, the optimizer, that this plan is better than another?
It isn't parameters. It tests the statement. It looks at the statement during the evolution process, and I evolved that plan through the auto task. It was automatically accepted. It was verified automatically. You can do it manually as well through the evolve procedures, which would be evolve SQL Plan Baseline, and that's a heavily overloaded function. But what the evolution process does, it simply tests the plan. It probes the tables to see if the statistics are correct. It partially runs the statement. It experiments with different execution plans to see which one is better. It gets its own timings. It simply tests the statement. And if you look at the report that comes out, it does tell you, for example, how long it took. Yeah, the plan was verified in that many seconds. And so depending on the complexity of the statement, if the statement is 500 lines of SQL and takes 500, it takes 5 hours to run, it isn't going to run the statement to completion, clearly, but it will still be able to start it off and try it and see how it gets on. And within limits, it will do what it can. The default limits are, for example, that it has only 1 hour to do it. You see, these are all settings that can be changed, by the way.
So it's actual statistics, runtime statistics in a sense.
In a sense, it is. In a sense, it's runtime statistics. Though for a huge query, of course, it can't run it to completion.
Great. John, there was also the notion of SQL profiles. Are they doing the same thing?
They have a similar effect, don't they? But SQL profiles, I don't much like profiles, partly because, of course, there's licensing, the Enterprise Edition plus Tuning Pack, but also they're covering up problems. The optimizer's fix coming up with a bad plan. The profile lets it correct that plan. It isn't fixing the problem of why did the optimizer get the wrong plan in the first place. And that's where I think baselining takes it to another level. It really does let Oracle work out what went wrong. What was wrong with the one plan? Why is another plan better? So yes, there's a big overlap, but it's a very different approach.
Stored outlines still available, John?
Oh, they certainly are. Stored outlines, and I love stored outlines. Been around since 8 point something. They're still there. They're officially deprecated. They're very easy to use. I must say, if as a get you out of trouble in a hurry technique, a stored outline might be the way to go. There is, however, a procedure in DVS SPM to convert your stored outlines to, oh, there we go, to convert your stored outlines to baselines. So yes, they're there, they still work, but pretty obviously Oracle wants you to move to better functionality because a stored outline is just a set of hints. There's no concept of evolution. It freezes the statement for better or worse forever.
You might have mentioned this, John, but SQL profiles do require Enterprise Edition and the tuning pack. Just a note.
Yeah, I think so. And there isn't much automation either. It's the sort of thing where profile might be very useful for a while to get you out of trouble, but maybe a couple of years later, it's still there. And it might even be causing problems a couple of years down the line. There's no concept of evolution or testing. It's not as rigid as stored outline because there is still hard parsing, but it isn't as flexible as the baselining mechanism.
If you liked this video, please like it and subscribe to our channel.